There are moments in the history of astronomy when everything shifts because of a single object, a strange signal, an impossible trajectory, a behavior no comet or asteroid has ever displayed. And right now, drifting through the cold darkness of our solar system, there is an interstellar visitor raising far more questions than answers. Its name is 3I/ATLAS, and if current calculations hold, then on March 16, 2026, this object will pass through one of the most gravitationally sensitive regions in the entire solar system. But what's even more unsettling is that its trajectory appears to be adjusted in a way no natural comet should ever demonstrate. Today, on Ultimate Space Secrets, we continue our investigation into 3I/ATLAS, the interstellar traveler that may reshape humanity's understanding of the universe. So sit back, because what you're about to hear will challenge the very physics we thought we understood. 3I/ATLAS first entered our solar system this past summer. It is the third interstellar object ever observed, after Oumuamua and 2I/Borisov. But unlike those earlier visitors, 3I/Atlas brings with it a series of anomalies that defy all expectations. Today, it sits about 300 million kilometers from Earth, and in less than 3 weeks, it will make its closest approach before vanishing back into interstellar space forever. Under normal circumstances, comets moving away from the Sun fade, quiet down, and lose their tails. But 3I/ATLAS is doing the exact opposite. It remains bright, highly active, and continues producing incredibly sharp tail structures week after week. Large professional telescopes have had limited viewing windows, but amateur astronomers with backyard telescopes pointed at the sky each night have captured the most revealing images. And those images show unmistakably 3I/ATLAS is not acting like a natural comet. In the images, 3I/ATLAS has two distinct tails. One tail points away from the Sun, perfectly normal, but the other tail points toward the Sun, stretching more than 1 million kilometers. This is not an illusion, not a viewing angle trick. It is a real physical structure. The solar wind here blows at 400 kilometers per second. Meanwhile, natural comet gases vent at around 400 meters per second. A velocity mismatch of 1,000 to 1. Under those conditions, no natural material should be able to walk into the wind, let alone form a laser-straight million-kilometer column without being shredded instantly. Astrophysicists call this the ram pressure problem. Their calculations show that for this anti-tail to exist, the material must be at least 1 million times denser than the surrounding solar wind. That means 3I/ATLAS would have to lose around 200 tons of material every second. Over 2 months, the total loss equals roughly 10% of its estimated mass. A natural comet losing that much mass that quickly should break apart, fracture, collapse, or at the very least, dramatically distort. Yet 3I/ATLAS remains perfectly intact. This forces scientists to ask the question, could this mechanism truly be natural? Throughout the summer, 3I/ATLAS behaved like a solid rock. No non-gravitational acceleration, no signs of gas jets pushing it. But the moment it slipped behind the Sun, into a zone where Earth-based observatories couldn't track it, something extraordinary happened. instruments detected a measurable acceleration. To explain this through natural cometary outgassing, the object would have needed to lose another 10% of its total mass in just a few days, meaning the total mass loss would exceed 20%, a catastrophic level that should destroy any small comet. Yet 3I/ATLAS didn't flinch. Several researchers have demonstrated that the acceleration profile fits artificial propulsion models far better than natural gas jets, whether chemical thrust, ion propulsion, or another form of directed propulsion. The math aligns. The trajectory aligns. The structural stability aligns. A comet's coma, the glowing cloud around its nucleus, does not rotate with the nucleus, so the brightness should remain relatively consistent. But 3I/ATLAS breaks this rule. Its brightness fluctuates 10 to 20% across a rotation cycle of 16 hours. This suggests a directional or structured light source, not random natural outgassing. Meanwhile, the anti-tail, millions of kilometers long, remains perfectly straight, unaffected by the object's rotation. This level of stabilization resembles a controlled orientation system, not natural comet behavior. Once again, the data hints at something more structured, more deliberate. It's important to emphasize, these non-natural theories are not coming from wild speculation. They arise directly from the observed data. Some well-known researchers argue that 3I/ATLAS may not be just a comet because its trajectory aligns suspiciously with gravitationally strategic regions. Its acceleration behavior resembles deliberate control. Its tail dynamics contradict natural physics, and its overall path appears guided. Through orbital modeling and dynamic simulations, they propose that 3I/ATLAS might be releasing a satellite or probe near Jupiter to gather data on magnetic fields, radiation, or other environmental conditions. This hypothesis is not treated as fantasy. It is based on physics. Yet, running parallel to this viewpoint is the official stance of NASA and much of the astronomy community. According to their spectroscopy readings, coma composition, dust structure, and reflectivity, 3I/ATLAS still fits the profile of a natural, though highly unusual, comet. No dataset so far conclusively proves artificial origin. And that is why many scientists stress the importance of staying open-minded, not jumping to conclusions, not forcing a narrative. This is one of the rarest chances humanity has ever had to observe an interstellar object this closely, with this much data. The truth is emerging, but it needs time. The most recent orbital calculations show 3I/ATLAS heading toward Jupiter's Hill sphere, the region where Jupiter's gravity overpowers the Sun's. Humans use this region to park satellites, stabilize probes long-term, reduce fuel consumption, and maintain observation platforms. For an interstellar object to randomly strike this exact region, the probability is incredibly low. This is why some teams consider it the biggest red flag, or perhaps the biggest clue. In just 18 days, 3I/ATLAS will make its closest approach to Earth. Every major observatory will be watching. The next few weeks may reveal. If the object fades, loses its anti-tail, and behaves normal, it may simply be the strangest natural comet ever. If the activity continues, the anti-tail persists, or the acceleration increases, natural models may begin to crumble. And if the March 2026 Jupiter encounter lands exactly within the Hill sphere as early predictions suggested, the artificial hypothesis will no longer sound far-fetched at all. So the real questions are these. Is 3I/ATLAS a rare natural phenomenon, a message, a probe, or a technology far beyond ours? Are we witnessing new physics or engineered interstellar navigation? What do you think? Share your thoughts in the comments and subscribe to Ultimate Space Secrets for the next updates on this unfolding cosmic mystery. Because this story is only just beginning. The universe is full of secrets, and together we're getting closer to uncovering them.